Alright, the control bracket. The distance to the center of this upper radius is 51. You can either cut the curve or you can add the circle or add the arc. We are at a 60-degree angle. Counter bored hole. Again, since there's only one, maybe instead of setting up the hole tool, it'd be easier just to cut the hole and then make the countersink. The problem really comes with these two cylinders here on the back, these raised cylinders. We need to add a plane. Again, if we have a midplane, we can extrude symmetrically. But then it's the offset distance, the amount that these hang over this machine surface. It's 3 millimeters. We can enter basic mathematical equations into the spin box. We do have larger radiuses of 6, and then casting fillets that are a radius of 3. 51 to the center is to the bottom surface. Then we have these two small holes. We need to add a plane, and in this case, an offset plane. If we reference a flat face, we can put a plane up above and then cut down. If we can find some way to put one in the middle and cut up, you could do that as well. But let's take a look at this one. So we have to end up getting these small little holes, which we will hopefully add some sort of plane and then sketch on this plane and then cut down. This one is in millimeters as well. Most of your dimensional information is here in the front view. Up and over, my 60-degree angle, and this one's perpendicular. You should get a perpendicular reference. You can create a perpendicular constraint, or you can measure this out at 90 degrees. But perpendicular snaps pretty readily. Finish this off here. Trim these off. Make a nicer intersection. In terms of adding some dimensions, we have an overall length across the bottom of 140 millimeters. A base material thickness of 19. That 60-degree angle. This is a true length measurement at 90, and then 51 to the center of what will be that cylindrical end. This section is a width of 18 millimeters, and this section is a width that is parallel, 19. If you get an angle measurement here instead of a distance measurement, they are not parallel. You can add a parallel constraint. By extruding symmetrically, you will then have a reference plane later on without having to add a midplane if you opt to do so. I'm going to come right to work here on the top. I cannot cut and extrude at the same time. So I'm going to opt to create the material so I can then cut away from it. I'm going to start by cutting out this rectangular section. And we have a width of 22 millimeters, and that is 6 millimeters deep. By referencing this face here, I have a counter bore cut of 32 that is 9 millimeters deep from the top. Sorry, this surface. 9 millimeters from this surface down. I'm going to sketch a circle. It is 32 at 9 millimeters deep. Minus 9. And then I have a drill hole diameter that is a tolerance of 1895 to 1905. Hole number 19 works out well. It is within tolerance. Less keystrokes. This grooved angle cut. You can mirror this sketch. It is symmetrical. A couple extra dimensions I don't think is going to hurt. So it is 42, so 21 and 21, because this is to a midpoint. It is not to the midpoint. So 21 and 21 is 42, which should give me 11. Correct. This groove is 6 millimeters deep, and the angle is 30. $30. We will cut this all the way through. I have 2 drilled holes. It is centered by using the midpoint, and now I can create my circles, which both of them are equal size, and the diameter is 13. Distance up from the bottom is 29. Distance from center to center is 28. These 2 holes will be cut. Okay. Creating this section here on the back side, since I already have created a midplane, I'm going to reference that midplane. Start with a block of material. There's a groove that goes through the center, and I am then going to opt to cut in underneath, since that is a measurement that I do know. Set these, and now start adding my dimensions. So the distance from the bottom is 51 to the center of the circle. (19) not degrees. (19, 29, and 19). And we have a distance down from the center of 25. And we need a distance in from the end, which is 14. All black construction lines means this is confined. I'm going to extrude symmetrically an overall width of 19 times 2. We could do 1. 19. That's the radius that sets these cylinders on the top. We can mirror features, which is what I would opt to do. I am going to extrude in 2 directions. No, I have to cut underneath. I set this up to cut underneath. I'm going to do all the work on one side and then mirror those features to the other side. I'm going to cut underneath. I've made a contour. I'm going to cut this in 3. I'll cut my hole, which is a 19 is within tolerance. I'm going to create the hole on the top. So by selecting this face, I can add an offset plane. I'm just going to bring it just above No, like out of the screen above. And I am going to draw a hole in here that is centered. This hole is a diameter of 3. And the distance in from this back edge is 9 millimeters. When I go to cut this, I want to cut it just so it goes through the top. That will work. Now I can add a midplane, and I can mirror multiple features off of this midplane. So I have the cylinder, I have the drilled hole, I have the undercut, and all of that is going to get mirrored to the other side. Oops, forgot the hole. Let's add a feature. Should have done them all at once. Done with the plane. Fillets. I would put your structural fillets on first. The radius is 6. And then your casting fillets. Run all the way around. Up under the cylinder. And around the base. These are all radius of 3. Material, machine surface. Material, cast iron. And machine surfaces. The bottom is machined, the holes are machined. No hatch pattern, holes. And then we'll hit those last 2 little holes on the top. Alright, that should take care of the control bracket.